I'm Jake Bruton, and welcome back to What Should I Use? And today we're going to talk propane. What should I use? A Build Original series hosted by me, Jake Bruton. So talk to me a little bit about what does trusted professional in this instance mean?
That's a good question. So trusted professional, in my case, and in most of the country, is going to require licensing, right? So we've got specific licenses that allow us and prove that we are certified to work with gas appliances, gas piping systems, from power generation to water heating, all right, to drying your clothes. We have nationwide contractors all over working with home builders, working with homeowners that are certified under national codes. Maybe their state that they're working in is dictating a specific license that they have to hold in order to do that. But certified professional, a lot of what we're talking about so far is not a DIY kind of scenario or realm that I think most homeowners should be looking at doing themselves, although they may be allowed to do that where they live.
Yeah. And so if it sounds like Eric is obfuscating or being slightly vague, you are on purpose, because there isn't one single national license for this. There isn't one single national governing code, where in the rest of our What Should I Use episodes, we talk about the IRC, which is governed by the ICC. There are fuel gas codes inside of that. There is statewide things for, say, Minnesota. But depending on where you live, the licensing and the license you might need to hold for fuel gas might be lumped under plumbing. It might be common for an HVAC professional to hold that same license. It is different testing in different municipalities, and that's why we're not making one distinction, but what we are making a distinction for is licensed and insured professional. And there are plenty of other things where we say, like, I'm not sure that I push too terribly hard for licensed builder. I'm not too terribly sure that I would push very hard for a roofer that has a specific license that they've been accredited by some bureau or anything like that. But I absolutely would not have an unlicensed gas fitter on my job conducting work. That is a completely different realm of responsibility. And this is something that, if done by a licensed professional who is paying attention to what they're doing, is absolutely safe. We're not concerned with it being unsafe in any way. It's the same way as having electricity in your house done by a professional. We're not worried about its safety. People hear combustion and they start to have some sort of panic because they think combustion and fire. But we drive around the country every day in something that has combustion sitting in front of your knees, right?
Yeah.
It's a controlled combustion, and when done by professionals, we don't have that concern. We don't have worries. It's only when things are done in an unsafe manner by non-professionals that we would ever have a concern. And that goes for electricity the same way, or structural components of a building the same way. Like, if it's not done by professionals and not inspected, that's when you have the concern.
Well, and beyond the professional too. So appliances are manufactured to meet a whole slew of industry standards that are dictated by not just local governing bodies, but national. Think UL Laboratories, or CSA, right? So like you're looking at certification boards, testing agencies. They're saying that these appliances that we're placing in our yard or in our home all meet these standards, of so much of it having to do with safety. Of course, performance is the other thing, and performance could be easily tied back to the professional. So not only does the professional have to install and work in a safe manner, and so that they are handing over a very safe and completely normal system to be in a home, but they also have to, you're relying on that professional to size the piping system properly so that it delivers the proper amount of gas, in this case, to your appliances, so you have the proper performance. All of the things we've talked about so far, power generation, water heating, even just boiling water on your cooktop, has to be seamless, and it's going to only be that way if it's been installed properly. Like, I can undersize gas lines and have poor performance, and you're going to hate me for it. But because I'm working under the guise of code books that dictate how things have to be sized, how they have to be installed, protected, everything that goes along with that, just like you're calculating load ratings on your roof, right?
Yeah.
So you're having to follow those guidelines. We have to do the same thing with gas, regardless of the fuel.
Okay, now we have brought in Eric's bag of goodies. I think he travels everywhere with this. Let's start with, what is the book that you have in your hand?
Okay,
Eric?
so this is the Minnesota Mechanical and Fuel Gas Code. So it's an ICC document.
Okay.
Amended for Minnesota just for some brief safety things that get put into code documents all the time. A lot of states in the United States are working on their own version of a larger code, right? With plumbing in Minnesota, we're using the Uniform Plumbing Code, but it's a Minnesota amended version of it. Not uncommon to see that with fuel gas codes as well. But this is what governs everything I do, propane or natural gas, in a gas piping installation and service.
And so when we're talking installation, there's safety in here, there's sizing, there's allowable materials, like there's testing procedures, there's this is...
Take a look.
Yeah, this is your day-to-day manual, basically.
It is, and just like any code, it's updated and adopted. Those updates are adopted and put into place. I can size piping systems, like you said, the venting systems as well, and some of this will then hand off to the manufacturer for when it comes to like appliance installations.
Yep.
But again, those manufacturers are dictating those installations and all of the parameters around it based off of those international testings and certifications.
And they're aware of what's in here too, and they're going to not violate this in reverse as well.
Correct.
Because they know what you're supplying to their appliance.
Absolutely, yep. So that's number one, safety, sizing, performance, everything that governs and literally is looked at and tested. It comes from a document like that where you're professional, where you're living and working.
Yeah, we talk about industry council and we talk about the opportunity to follow their guidelines or their rules.
So then materials, right?
Yep.
So we've seen basically the same types of materials for decades and decades when it comes to plumbing and gas, right?
Yep.
The last few years, maybe starting about 20 years ago, we started seeing a couple new ones. The last couple of years, we've seen a few more advancements in materials when it comes to the installation, pretty much outside of the building, right?
Okay, are we starting old or new?
We're going to start old.
Okay.
Everybody's familiar with iron pipe, right?
Yep.
Okay, so black iron, galvanized. It could be your local code body enforcement might dictate that this is the material you're going to use inside the building.
There are a couple of municipalities where I am that this is the only thing that is allowable.
And that's interesting because I live in an area that, Minnesota's had a fuel gas code and a plumbing code since 1918, I believe. And you would think like somebody that's had a well-established code and is pretty strict on those codes and enforcing them would stick to something that they know is like, this is what we use, is the only thing we're going to use. But it's not. This is like one of the least common materials we use for gas pipe installation. This is great, and there's no reason not to use it. It's just labor intensive, so like a lot of the industry has tried to push toward other materials. Because
you're going to have to put your own threading on the end of it. It's not as easy to cut as some of the other things. There's some challenges to this. It is hard. It is heavier. It's a little more difficult. It
takes more specialized tooling as well, right?
It does.
It's reliable, it's super robust, just like any gas piping system. There's things like electrical bonding involved, stuff like that. But not to get into the details of how to install gas piping, but those are the most common iron pipe.
And longevity-wise, we're talking 50 to 100-year piping, right?
Easily, yeah, absolutely. More common with propane installations, though, is copper. So this is a type L copper. There being three basic types of tubing that we're working with when it comes to water and gas. Type M, our codes don't allow us to use type M. That's the wall thickness for gas piping. Type L being the minimum, okay? And because it's a minimum, it doesn't mean it's the least reliable or strong tubing or best product for the application. It's just, it meets the standards that we are governed under for gas installation. So with propane, all across the country, copper is a very common material. This being what we call soft copper. It's been annealed, so it's flexible or more flexible. Otherwise, the same as any other copper tubing. Okay. Type L, you've seen that coming off of propane tanks outside, run over to the house to a regulator that's typically mounted on the outside. Connections there would be flare connections instead of threading. We're not soldering this like we would with a water piping. It could also be brazed which is a different form of soldering, I guess, using a filler metal and a fitting. But typically we're installing this material with a flared end and a nut and ferrule type of situation.
This is absolutely what I remember running from our propane tank over to the house.
Absolutely the most common material from the tank to the house for sure. In Minnesota, it's very common to see this inside the house. It's been that way since I think about the 50s or so, when soft copper became more commercially available out in the marketplace for building.
Okay.
All right, moving on. Inside the house still, okay? Or let's go outside.
Okay.
Let's stay outside. This material here, does it look like to you?
It looks like something that I've seen run with water lines, but not in yellow.
Yeah. So the yellow indicator would be very quick for the professional in the field to identify that as a gas distribution pipe. It's polyethylene. It's not PEX, like we would run water through. Dimensionally, it's slightly different, so we can't interchange the fittings.
Smart of them.
Yes, very smart. This is a polyethylene tubing, and this is what is used in network for gas distribution systems all over the country.
Yep.
All over North America and probably the world, okay? I don't work in other countries, but I know for North America, this is very common, and it's starting to be in place in replacement, I guess, for the copper from the tank to the house. Not uncommon at all. There's some different fittings that have to be used, like I said, and they're specialized to the size of the tubing. Tubing comes in all different sizes because, of course, the size of the tubing dictates the capacity that we can deliver through it. But very safe. And to be completely honest with you, super easy to work with, right? We're actually using it like a stab-on, push-to-connect type of fitting with this, with anode type or anode-less risers coming out of the ground. We have to run a tracer wire with this because now we're no longer we're no longer metallic like we were with the copper.
Yep. So I have only seen this being installed by municipality. I have not seen this in a plumber's hand in my market yet.
This chunk is off of a roll from right in my shop. I use it when we're looking at installations we're adding onto systems. So we've got a tank in the yard already. I'm rural in most cases where I'm working, not entirely. So propane is very present where I'm at. And we might be working with a customer that's just added an outbuilding. And with that outbuilding, they want some type of heat. And we're going to tap into their LP system, bury this, direct bury, over to their new outbuilding. Now we've got a gas line. And it was really simple to install. It was lower cost per foot than a material like copper. And it's less likely to be damaged because it's a more flexible material. The wall thickness is tremendous, and it can take a lot of, let's not call it abuse, but I guess being buried out in the yard, it can handle that.
And you're not going to kink this the way you might the soft copper.
Correct. It's less likely for sure in the installation process, so it's not likely you're going to have to make any repairs.
Yeah, and your labor is substantially less on this guy too.
Anytime we can cut down labor on the professional side, on the installation side, it's good for the company, and it's also good for our customer.
Yeah.
All right, let's go back inside. So I mentioned with the copper in Minnesota, it's very common to use copper for distribution piping, all right? Especially with LP. But this is another material. It's called CSST, which stands for corrugated stainless steel tubing. And so it's called that because it's literally stainless steel and it's corrugated.
Yep.
Okay. This is an older material. Admittedly, I brought it from some scrap out of my shop because there's some variations to this material. Been on the market since the early 2000s. It became really a favor for new construction then because we had a serious issue with copper being stolen off of job sites. This is a tested, certified by every code body and agency for use in gas distribution. It's identified with that yellow jacket on it, right? Be careful, it's a little bit sharp.
So we know it's for gas.
Yeah, so like the universal color we're using for piping systems is yellow for gas. This stainless steel tubing, some different fittings. Now it's kind of like a flared connection on the end, but we're not using a mechanical tool to make that flare. It's made inside the fitting. There's electrical bonding requirements that go along with this. All of this is...
Because it's metal.
Yep. All of this is going to be dictated by the manufacturer, and it's the code materials are going to point to that manufacturer. You have to follow that. In fact, there are actually certifications for these specific tubing, this stainless steel tubing, by the manufacturer. So if you're going to work with different manufacturers, you might even have to have a different certification for each one. They're all pretty close, but slightly different. This is an older material. Like I said, it's scrap out of my shop. I've used it for a few different videos. They make an additional kind of just an advancement of this that has some electrical bonding built into the jacket.
Oh, so you don't have to pull separate.
Correct. So
nice.
Yeah, so that was an advancement over time that they saw that how they could improve the material.
Very smart.
Very common in new construction, especially because of labor savings, right?
Yeah.
So flexible material, it's code approved, it's perfectly safe, and it can be pulled through joists, trusses, very, oftentimes by one person rather than two.
Yeah, I've helped fish this. This is about as easy to fish as water lines, as PEX lines.
I want to point out, though, to everybody watching, so this is very similar to what would be like an appliance connector looks like right?
A whip.
Right, where you buy it prepackaged with the connectors on the end of it, maybe some fittings that you're going to add into the system. This is not that, okay? Those are certified sized. They have ratings for the specific length and diameter. Yep. They're made specifically for that application that they're packaged and sold under. This is a bulk tubing that we're assembling on site, the ends, and we're running sizing for proper distribution and performance, right? All of these materials, though, have safety requirements when it comes to passing through walls, floors, protection of pipe, just like we would protect our water piping. We don't want nails, finish nails, wallboard screws, anything like that going into this tubing for very obvious reasons. So there's a whole class and chapter and just amounts of certification parameters that come into the installation of these materials within the building.
From nail guards to supports to just absolutely everything, the way we would protect electrical wires or plumbing pipes.
And even more so with tubing like the CSST, where it's passing through stud members. There might be additional sleeves that are installed onto it to protect like the bend radius, things like that, so it doesn't become kinked. All things that your professional are going to be working aware of. And if if they're not aware of, or you're questioning that, you can go straight to the manufacturer's installation manual, and it's going to have all that information. Is going to be free to the consumer, to the builder, to the contractor. All of that's going to help even just kind of verify that it's being done right.
Absolutely. So I see you do have some safety stuff. Well, we have a few more fittings actually, right?
I brought some fittings just because I love I love traveling with my big case of stuff. And so this one, I filled it with a whole bunch of different stuff. Okay, so this right here, iron pipe. We started the conversation with iron pipe because it's the most common. And you talked about threading. Okay, so we actually, look at that. We're actually using fittings now where we're pressing onto the outside of the iron pipe instead of threading.
So we're threaded here, but these guys are a mechanical press.
Yeah, there's a term, there's a brand terminology put out there by a manufacturer called Mega Press. It's kind of been adopted as the Kleenex because that is truly a branded name. But we're using what we call Mega Press in the industry, and that's a very safe, proven, reliable piping connection.
Yeah, it's a mechanical crimp, basically.
It is. It's permanent. Although some people may not be familiar with it, believe it or not, with iron pipe, we've been doing this for about 10 to 15 years now, and for gas, about just under 10 years, the certification for the use in gas. It's not the same fitting we would use on a water system. It has a specific seal, that's that yellow colored seal in the fitting.
Which there's a yellow seal inside there. Molecules are different sizes. They do different things. They interact with the pipe differently. The pipe sizes are different sizes.
Absolutely. The pressure in which to crimp that or press that material onto the pipe, all of the fire ratings, because there are fire ratings with this when you start comparing that connection to the traditional threaded connection. Obviously, we're familiar with this, so we start to question that. That meets all of the safety standards, codes, certifications, you name it.
I think of this jump as the same as when we went from framing 16 inches on center to framing 24 inches on center. I had people go, oh, well, you're doing something different, so it must not be safe or something like that. And it was literally just a conversation of, you just haven't seen it before, and that's the reason you're questioning it.
Yeah, absolutely.
Once you're educated on the material, and once you've bothered to look into the engineering, this is going to be a time saver. This is going to make your life easier, and we're not giving anything up.
We're not, and we'll get into a little bit of why that is true in a minute. Let's just go through the rest of the material real quick. Here's a copper fitting that is a press fitting. It looks similar to what you see, what we call the ProPress system. This actually has the yellow seal in it instead of black like we see with water. It's got a marking on the outside that indicates this is not a fitting used for water.
Yep.
It is certified for gas. In certain parts of the country, we can use copper for gas distribution. In Minnesota, it's very common, like I've already talked about. We can actually press onto that copper instead of flaring it.
Okay.
And it's a perfectly safe and certified way of doing it, and completely reliable. It's been around for way more than 10 years.
Okay.
Pretty common to see in my neck of the woods, not common everywhere. So some people watching this are going to say, well, we can't use copper. It's worth bringing up because it is common, and some of the people watching this might see copper in their house for gas distribution.
And there's some of the like, oh, well, we can't use it in our market. That's local municipality. That doesn't make it not safe. It just means your municipality says you can't use it.
Yeah, for whatever reason. There's a lot of reasons why, and it's becoming less and less normal for that. These things are becoming more and more widely adopted.
Yep.
Threaded, just back to the basics,
Old
right?
school.
Old school, but reliable.
Yeah.
Completely reliable, more labor intensive, but very strong sound connections. Mistakes can be made with all of this, right?
Yeah.
That's why we're working with professionals. Hopefully they're making sure that all the rules are being followed on the installation side of things. But no matter what, all of the stuff I install, anything permitted, anything not permitted, even if I was working at my own house and I was gonna make a small repair, we test everything.
Yep.
We're not talking about water here where you could just see a leak. It may do some damage. We may have a little heartbreak.
Yeah.
We don't want to leak with gas ever, right?
Yep.
Not because it's an immediate, like, crazy danger, shut down the whole system, but because, for obvious reasons, there's a lot of implications if we were to have a leak with gas.
Exactly.
We test everything, and we use a lot of different tools. Let me grab them here. One of the most common tools is, you might be familiar with something like this.
Yep.
You guys use it connected to a blower door,
We do.
maybe?
Yep.
We use a manometer. This is being digital. I actually have a analog one as well. I use a digital manometer all the time with gas systems. It's probably the number one reason I own that tool. It can be used for multiple purposes, but we check for leaks at the very most minute measurements.
So you're talking about going around to all of your connections. You're checking everything.
Actually, so my manometer is connected to the whole entire piping system. I'm isolating at things like appliances so that they can't turn on and run. And I'm pressurizing the system and checking for a leak using the manometer under inches water column measurement. So very tiny amount of leak. And it doesn't identify where the leak is. It tells us if there is or if there's not a leak. And we could do it with digital or analog, and I have to have both. In fact, sometimes I check one against the other because maybe I have trust issues. But it's a tool that every qualified contractor working with gas systems absolutely should be using, has to know how it works.
Yeah.
It's akin to using a voltage meter, a multimeter, as an electrician. This is what needs to be used with a gas system.
This is a daily tool.
Absolutely. I have even a backup for my main tool, just in case, because it's a tool that needs calibration or it's only good for so long, things like that. I want to be sure that everything is right. Very, very important tool. And we're using this to verify we don't have leaks. And in fact, where I work, because we know it's different already, we've established that, but where I work, my permitting on a job for gas piping installation does not end and isn't signed off and completed by the AHJ. They're actually proving to them that there isn't a leak. And so they're not completing that permit process until we've shown them a test. And all of the municipalities I work in, they're saying manometer. So make all of your piping connections. Think about new construction. We do the rough in. We show them an air test. I've got another gauge just to show you that, but you know what an air test gauge looks like. Yeah. We're connecting an air test gauge on the rough in piping. We're pressurizing it to what the code standard says. Code enforcement has to sign off on that, just like your footing inspection or just like any type of inspection along the way in construction. Our final inspection, when we can say we've turned this over to the owner, the client, whoever, includes the manometer test.
Yeah, the code addresses health, life, and safety first, right?
Absolutely.
Okay, so if that does say that you have a leak, how would you go about trying to find that leak, though?
I just bought a new one of these, and because I just love tools. Actually, I'll be completely honest with you. I bought a new one because my old one was left on a job. So there you go.
Oh, I get to hold the tool.
Yeah, so this is what we call sniffer.
Okay.
Battery operated, electronic, obviously. There's a diode in the end of this that's looking for combustible gases.
Okay.
And so this is a tool that's familiar, you might be familiar and have seen somebody from a gas utility company or the propane company or fire protection. You see, you let's say you smell gas at your house, you call the fire department, you call 911, you call somebody and say, I think I smell gas. They're gonna show up with a tool just like this.
Yep.
Very basic, very common. It just is gonna sniff out and pinpoint exactly where a leak is in a piping system. Then we have to repair it.
Yep. And it is sensitive enough that you can run along a line and it will give you a change in reading, and you can shut things off and make repairs, and this is a tool that is going to change the way that you operate in your investigation process should there be an error.
Yeah, look, even when I'm using my manometer to check under pressure to check if there's a leak, I'm grabbing this tool because we want to test over time. We don't test, it's not a 1 minute test.
Yep.
We're testing over like a 20, 30 minute period so we can truly make a good, accurate assumption that there is or is not a leak using the manometer tool. But while I'm doing that, I'm just going around and checking. There's a little parts of the system that may be a problem, like valves with the little packing glands on them. Sometimes they're loose at the factory. Things like that, I'm just verifying everything. It's like a checklist, right?
Yeah.
It's my to-do list. It's my checklist as I'm verifying everything's good.
Yeah, you have a final safety walkthrough.
Yeah,
right?
Yeah, absolutely. So normal tool, pretty cool too. I like this one because like you said, I can go in the room and I can kind of cloud measure and then I can pinpoint, which is really cool. It just makes me more efficient.
So when I was a kid, we had a big propane tank in the backyard. We lived in a rural setting, which I think most of rural America is very familiar with the propane tank. It is a means of having the ability to have combustion appliances inside your home if you live rurally where there isn't services for other means of combustion, right?
Yeah.
And that's kind of popular in your neck of the woods too.
Absolutely. Tons of propane, gas appliances, heating appliances, cooking, clothes dryers, you name it.
Yeah, so growing up, we had water that was heated by propane. We had our source heating for our home was propane, and we had a dual fuel stove or cooktop in our house that was propane. And there is quite a bit of utility. I kind of at the very beginning said we're going to talk utility first. So let's have that conversation, and we kind of have two of those items here. So let's start behind us. Item number one, when I said water heating in the old school way that's still perfectly popular today,
right,
we have the tank system for heating water. But this system behind us, we have a tankless unit. Let's talk a little bit. We can talk safety, but we can talk about, how many of these guys are you putting in on a regular basis? Tankless is very popular today, right?
It is, yeah. So with gas tankless, we're able to provide pretty much endless amounts of hot water for any residential, light commercial, even commercial application, right? So gas water heating is probably number one in my area of the country, although second to electric nationwide.
Yep.
Very common, high performance, perfectly safe, and like you said, with the more modern appliances, tankless, my customers are super, super happy with what we can provide them because we have a gas-fired appliance.
Yeah, and when we say high performance, like not only is it high performance because we get quick access to BTUs, like it is an efficient process to begin with, but we also, in the tankless aspect, we're not paying to keep 40, 50, or 80 gallons of water at use temperature at all times. We're paying to keep maybe a gallon of water ready to use at all times. And there is a huge efficiency, and then we can quick access more as we feed it through the system, which I think that's one of the things that most people don't really understand about a tankless is like, that's where the true efficiency standard comes from, is like the rapidity at which we can go, okay, let's use the propane, let's access the BTUs out of that as fast as we possibly can. And now we have a system that's just like, all right, we turn it on, and that's when we start actually using the energy that we're going to pay for, right?
Yeah, so performance is number one, why we're even considering a highly technical appliance like a tankless water heater, especially when it's gas. But the technology built into it too, right? So like you said, instant and continuous. We're able to do that with gas, high efficiency, and it's condensing as well. So now that's where we're getting into that high efficiency or high performance levels too. So where you're looking at 95, 96, 98% or an AFUE rating. So all built into what's pretty common and normal for installations today.
Yeah. And so then we also have a conversation about the unit that's behind you as well. We have an on-site generator.
Right.
This is something that when I was growing up was absolutely uncommon in my neck of the woods. This is not something that I remember being in my neighborhood, even though everybody had a propane tank and everybody had propane in their home. I don't remember anybody having a generator, and I, at the beginning of my career, was not installing generators. And now this is something that's becoming very common. And I think that it's important for us to have the conversation about like the utility that this offers as well.
Yeah, so with propane, we can store it on site, and we can store really very large amount or down to a very small application base. So let's say you had just your cook stove in your home, you wanted to be propane, you could have a very small tank storage on site. If you wanted to have backup power generation, which like you said is becoming more and more common, you're probably gonna have a larger tank out in the yard. Some safety concerns we have to think about there, where how things are installed, but in that scenario, you're able to provide your own power on site. Super common now, or becoming more and more common, especially as we see more extreme weather events. People are living in areas where the grid itself is becoming more taxed or less reliable. Mm-hmm. And maybe that's tied to weather events as well. And being able to have power at your command with your own fuel, that's huge.
Being able to weather that storm, if you will.
Yeah.
It really is like the only opportunity that you have to generate your own power and have your own power source. Like, yes, you can have solar, but you need sun for that. And you can have other options, but this is I flip the switch and now I have it until, like, as long as I have my tank filled.
This oftentimes is a lower barrier of entry when you start comparing it to other renewable sources like wind or solar. This can install in just a matter of a couple days with less equipment.
Yeah.
And it can interlock with your, can be integrated right into your power for your home a lot more simply. And the bonus is having your own fuel stored on site.
I want to say thank you to Eric for joining me today. And I just want to say, I think that we have the resources at hand, the tools and the materials at hand, if we work with the right individuals, to utilize just about anything in our industry to move forward. And I think we have our wrap up for today.
Yeah.
So until next time, have a good day.